Hi everyone, this is Mr. Edwards. Today we're going to be covering how to graph a quadratic. Before we begin, you should actually pause this video and take a moment to review this essential vocabulary that will help you prepare for our graphing quadratics lesson. And once you're ready, then you can unpause and you can join us back in our lesson. Okay, here we go. Here are our goals for this lesson. We're going to graph and connect 5 points of a parabola like the one shown using patterns and transformations. And then we're going to analyze basic properties of a parabola like its vertex and intercepts. So in this lesson, we're going to have some guided notes, about 2 pages worth, and that's designed to be completed while watching along with me. And then you'll complete some independent practice. And then if you would like some additional practice, there's a great IXL practice that covers the second goal for today, which is analyzing basic properties of a parabola. So let's begin. We're going to begin by understanding the quadratic parent function, y equals x squared, in multiple representations. Multiple representations means that we're going to look at it in fundamentally different ways. We're going to graph it, we're going to try doing a table, we're going to read it in words. So in words, the parabola, the parent function y equals x squared, models the result of squaring a number because we have x squared. When a number is being squared, it's multiplied by itself. Here's the numeric approach. That 3 squared, for instance, is 3 times 3. That's what squared means, which is 9. So 3 squared is 9. 4 squared, that's 4 times 4, is 16. 7 squared, that's 7 times 7, that's 49. And x squared is x times x. And what we're going to do now is we're going to create a table for this parabola so that we can graph it, so that we can actually see a picture. So we're going to graph x versus y, which equals x squared. All right, so how do we do that? If we have a number like -2, we want to know if we're at -2 in the x, where are we at in y? So we plug -2 in for x, and we get -2 times -2, or -2 squared, same thing, and that's 4. We have -1, so -1 squared is 1, and then keep going. 0 squared, 0 times 0 is 0, 1 squared is 1, 2 squared is 4. Okay, let's graph. We have the point -2, 4, -2, 4, boom, -1, 1, -1, 1. We have 0, 0, 1, 1, and we have 2, 4, 2, 4. And we're going to go ahead and connect. And when we connect, I always like to make my arrows go all the way to the edge of the graph. And then here we go. See how good my drawing is with the stylus? Not too bad. All right. I've done better. I've done worse. Okay. So that is a parabola shape. You want to be sure not to make it pointy at the bottom. You don't want to make it look like a V. It should look a little more U-like. And that'll make it look more like a parabola. Let's look at our vertex. Our vertex is the full coordinate point that is right at the bottom or the top. It's right in the middle of your parabola. So that's going to be 0, 0, and that's a full coordinate point. We want to see if this parabola opens up or if this parabola opens down. So you want to look at where these arrows point. If the arrows point up, it opens up. If they point down, it opens down. So this parabola opens up. And that means it has what's called a minimum. A minimum means, does it bottom out, or does it look like a hill where it tops out? So if it has a bottom, then that's a minimum. If it has a top, that's a maximum. And actually the definition of a minimum is the y value for which there are no more y values even lower than that. So that proves that that's a minimum, because 0 is as low as it goes, and it doesn't go any lower than 0, this parabola. So we have a minimum. All right, let's keep going on here. So that table approach, a lot of students tend to think that's a lot of work, and they don't like doing that. So I like to show one or two tables, and it's a great skill to make sure you really understand parabolas. But to graph this a little bit more quickly, I really like the essential big idea understanding of what I call the 1-4 pattern for parabolas. So what is the 1-4 pattern? If you start at the origin, go ahead and take your pencil and put a dot right on the origin, right where that vertex is, and then put a line, a little arrow that goes over 1, and then we're going to go up 1. So we're going to go over 1 and up 1. And we can do that on both sides because parabolas are symmetric. So we're going over 1, up 1. Okay, so think of it this way. If you're starting at the vertex, my mind sees this as over 1, up 1 on both sides. It's the symmetric process, 1, 1. So the 1, 4 pattern means 1, 1, then you go over 2, 4. So here's what that looks like. So we're going to draw another arrow, but starting from the origin and over 2, because that lines up with our next dot. Over 2, up 1, 2, 3, 4. Over 2, up 1, 2, 3, 4. Okay? So this pattern of 1, 1, 2, 4, starting from the origin, that is a pattern where if you follow that pattern, you can graph any parabola that doesn't have any what's called a vertical stretch or vertical compression. So any normal parabola. So like even look at this. We go 1, 1, 2, 4. 1, 1, 2, 4. And I call that the 1, 4 pattern because if you think of it as like there's this little floor here, we go up 1 for our first dot, up 1 for our first dot, and then up 1, 2, 3, 4 for our second dot. So I call that the 1, 4 pattern, right? And if you do that for every parabola, it's going to make graphing these way easier. It's really important in math to make connections and find patterns so that your mind isn't working so hard. You want to make math more efficient. All right, so the 1, 4 pattern, to memorize the graph, the 5 points of parabolas efficiently, we want to be efficient with this pattern. So to reiterate, to see this in words, the pattern, we're starting from the vertex, then we go to the left and the right 1, and then up 1, and plot a point. That's what we did. Then go back to starting from the vertex, go left / right 1, or no, sorry, 2, and then up 4. So 1, 1, 2, 4. All right, let's look at some examples. We're going to graph some parabolas. We're going to graph the following using only the 1, 4 pattern. It's not even going to feel like math. It's very fun. So we're going to start from the given plotted vertex. Here we go. We're going to graph x plus 2 squared. You don't really remember what that means probably, but we are just following the 1, 4 pattern here. Here we go. 1, 1, 1, 1. Then here we go. Start from the vertex. 2, 4. 2, 4. And then we're going to make our parabola. All right, and try to round it out at the bottom. That is not my best drawing. Okay, so let's do the next one. All right, here we go. We got our new vertex, and we're going to learn how to graph these by hand without that little dot there on the next page. So this little scaffold for you. 1, 1, 1, 1, 2, 4, 2, 4. All right, and so it follows the same exact pattern, and that is correctly drawn now. All right, so not bad at all. And it's hard to do this with my stylus, but on your paper, try to make these a little bit neater so that your graph actually goes through all the dots. I can only do so much with my stylus. All right, so let's knock out the last one. We do have a negative here, okay? And we're going to learn about this on the next page, but it's okay for parabolas to open down too. If there's a little negative on the left here, it opens down. So here we go. 1, down 1, 1, down 1. And then from the vertex, 2, 4, 2, 4. Boom. All right. So back in your algebra class, if you did not learn this pattern and you only knew how to graph based on tables or by using your calculator, you probably found graphing quadratics to be very difficult. And this is actually a very difficult problem for students because there's a lot of transformations on this that you probably don't remember. But this pattern is going to be super helpful. Let's go on to the next page. All right, so we're going to now that we know how to graph a parabola, we're going to analyze a parabola or a quadratic's key features. So the vertex of the parabola, that's a full point x comma y that represents the maximum or minimum point. So that point, just by inspection, it's the point -1, 4. Does it open up or down? Well, just kind of visually, you can tell it's sort of cascading downwards, but really it's where do the two arrows point? And this one doesn't have arrows on it, but it technically should because parabolas extend infinitely. So those arrows are pointing down. It's opening downwards. Does it have a min or a max? So does it have a maximum or minimum? This one has a top. It tops out. It's a hill. That's called a maximum. So it has a max. What is the max or min y value? So that means how tall does this parabola actually go? And just by visual inspection, this parabola goes all the way up to 4, and it doesn't go any higher than that. So our answer is 4. That's the max value. So we only list the y value of the vertex. If you're struggling to figure out what is the max or the min, you always can look at the y value of the vertex, and that will always tell you the vertex is by far the most important point of parabolas. Very important. Let's look at the x-intercepts. You can either list just the x values or the coordinate points, and those are where your parabola crosses the x-axis. So that's at -3 and 1. So -3 and 1. Then the y-intercept. The y-intercept, you also can put y values or the full coordinate points. Both of those are technically correct. So you can just put 3 because that's where we cross the y-axis, or you actually can type the full coordinate point, which is 0, 3, which means that the x-intercepts also could be, you also could say, or the full coordinate point, -3, 0, and 1, 0. You could say either of those, but realistically, it's perfectly acceptable. It's fine etiquette to just keep the shorthand. And the reason why is because every intercept has 0 for the other value. So it's just like, what's even the point? So we might as well just write the only value that really means anything. Okay, let's go on to the last skill before we get to practice. We're going to determine the vertex using transformations. And then finally, we're going to graph using just our transformations and what we know, and we're not going to have that point, that starting point like we did on the last page. So the parent function y equals x squared always has its vertex at the origin 0, 0. So it starts right at the sort of the middle of your graph. However, transformations shift that vertex, such as we have up and down transformations. That's when we have a transformation or a number on the outside of x squared. So it on the outside really means like to the right of. So when we have an up 3 graph, an up 3 transformation, that +3 means that the vertex is shifted up 3. Okay, that's called the transformation. You're going to be asked on assessments, what is the transformation that this parabola has relative to its parent, x squared? And if you see that +3, you'll say up 3. That's your answer. Okay, so what does that mean? Usually we start at the origin, but instead we're up 1, up 2, up 3, and now we're here, up at 3. So that's what it means to be up 3, where we literally took our parabola and we moved it up 1, 2, 3. So the -2 in the next one, x squared -2, that means we are shifted down 2. So we went down 1, down 2. Okay? Let's do left and right transformations. So for left and right transformations, that's when we have a transformation on the inside of x squared, or we have an additional number that's inside the squared function that's next to the x squared. That shifts our parabola left or right, okay? But it's the opposite of what you might think it is. So when we have a +1, when we have that +1 on the inside with the x, that actually means left 1. So left 1, we usually start at the origin, but we're going left 1 instead. The -4 in the next one means right 4. So we usually start at the origin 1, 2, 3, 4, and now we're here. And then you can still do your 1, 2, 4 pattern, and then you can recreate your parabola. All right, last transformation we're going to do for the day. There are more transformations than this in the world, but these are the 3 types of transformations we're going to focus on just for this lesson, since this is just one lesson here. So we're going to do reflection across the x-axis, or when we flip a parabola, so it's like a pancake flip and it opens downwards instead of upwards. That's when we have a negative to the left of the x squared function, and that will make the parabola open down. Okay, so when we have this little negative, that's how we know our parabola is going to open down. And it has to be a negative on the left of your x, or on the left of your parentheses. So that's pretty much all the transformations. Let's just do one big example that we are graphing any shifted parabola, including an opens down example. We're going to determine all the transformations. When you're asked to determine all the transformations, that basically means in words, what have we been writing here? Like up 3, down 2, that kind of thing. The only difference is that the negative, we have to say the phrase reflected across the x-axis, okay? So we are reflected across the x-axis, which really is it's just a fancy word for saying we're flipped and we're opening down now. But that's the formal way to say it. So we'll keep it formal. And then we have this +1 on the inside, and +1 on the inside. We actually had that example. That's left 1. So we'll write left 1. And then we have a +5 on the outside. That +5 means up 5. Okay. All right. And then we want to determine and plot the vertex. So if we plot our vertex, we're left 1, up 5. The nice thing about actually writing this out in words is that you just follow the exact directions you just wrote out. So we're going left 1 and up 1, 2, 3, 4, 5, and we are plotting our vertex. All right, so let's determine the vertex now. Determine the vertex means write down what the coordinate point is. That's -1, 5. -1, 5. And you'll also notice those numbers show up in your transformation. And that's not a surprise. Okay. Now, we are going to use the 1, 4 pattern to plot all 5 points and connect. Over 1, down 1, over 1, down 1, over 2, down 4, over 2, down 4. And here we go. Try to get a really good parabola drawn for the last one. All right. Not too bad. Okay. It's a stylus. All right. So that's how you graph any shifted parabolas. In your Algebra 2 course, once you get there are a couple more transformations, but these are the ones that we're going to focus on for today. So go ahead and go on to the next page and give this some practice. And if you want some additional practice, there's a link at the beginning of these notes for you to get some online practice with the vocabulary as well. All right. Hope you guys enjoyed this on graphing parabolas. See ya.